Hi everyone, and today I'll be explaining even and odd trigonometric functions. What does even and odd mean? If a function is even, it looks the same on both sides of the y-axis, like a mirror image of each other. If a function is odd, it flips over the origin, and one side is opposite of the other. Which one of these functions is even and which one is odd? That's right, the one on the left is even and the one on the right is odd. Let's talk about why. The one on the left is even because it's the same on both sides of the y-axis. The one on the right is odd because the symmetry is around the origin. But what about sine, tan, and cos? Well, sine is an odd function. It flips over the origin and can be expressed as sine at negative x is equal to negative sine at x. Tangent is like sine. It's also an odd function and can be expressed the same way, just with tan instead of sine. Cosine, however, is an even function because when you plug in a negative, the output would be the same. Moving on to real-life applications, engineers use cosine's even function to model for electricity waves, and they use sine's odd function to model for vibration waves. Let's try a practice question. A bird is flying a wavy path that can be written as h at t, 3 sine 2t, where h is the height and t is the time. What is the bird's height at t pi over 4 and negative pi over 4? So we're going to take the original equation and sub in pi over 4 and then sub in negative pi over 4. We're going to solve the question like we would a regular trigonometric equation, leaving us with 3 and negative 3. So we would write it as h at negative 4 pi is equal to negative h at 4 pi. So what does this show? It shows that the function is odd. Now we write our concluding statement, box off our answers, and now we're done. Conclusion, even and odd trig functions show us that symmetry behind sine, cos, and tangent are those same patterns that appear in real world sound and light waves. Thank you for watching. Hope you learned something.